Hello students. So this is the 7th standard new lesson algebraic expressions. I am your Shruti teacher. See here, algebraic expression you have studied before also. That means algebraic means it indicates the alphabets. Okay, it includes the alphabets here. If it is alphabets, the numbers in a number system, what you have studied, the different types of numbers, natural numbers, whole numbers, isn't it, and integers and fractions, again decimals. So these kind of numbers you have studied, but together this one we are added or we are included alphabets. So we are included the alphabets as expressions. Okay, those are called as algebraic expressions. The definition you can see, algebraic expressions are formed from variables and constants. See, constants are nothing but the numbers, the different types of numbers that I said, no, natural number, whole number and all. Variables are nothing but the alphabets. So those are nothing but alphabets. Okay, then the including these both make a or a form a algebraic expression. Expressions are made up of terms. So expressions are made up of terms. The terms means if it is something 2x plus 5y. Okay, see here 2x is a and 5y is one term. So these are the one term, it is second term. So two terms it includes this expression. That's why. And terms are added to make an expression. Terms are added to make. So here just now I have taken the example 2x plus 5y. See, this is a one term, second term. Okay, these are the terms. Then in this 2 and x, 5 and y, these are called as factors. Okay, so these terms are added or subtracted to make an expression. A term is product of factors. Just now I said, no, 2x is nothing but 2 into x. So 2 and x are the factors of 2x. Then a term is a product of factor. Factors containing variables are said to be algebraic factors. So 2 and x I have said, isn't it? So this factors containing variable and numerical variables. These are the numbers. Or here 2 and x are the factors. 2 is a numerical factor and this is a alphabetical or algebraic factor. It is a numerical factor and this is a algebraic factor. Okay, the numerical factors is said to be the numerical coefficient also we can tell. Okay, in 2 and x together variable, the number is there, means that number is called as a coefficient of x. Coefficient of x or coefficient of term also we can tell. So once again, if a 2x plus 5y is called as an expression, if you are taking, means in this 2x and 5y, so 2x and 5y are called as a terms. So these terms if you added to make an expression, okay, then these terms are made up of factors. So these are made up of factors as a 2 and x. In this 2 is a coefficient and x is a variable or called as a algebraic factor. 2 is a numerical factor, x is a algebraic factor. Here 5 is a numerical factor and y is a algebraic factor, or we can call it as a alpha numerals also. Then here I can examples I have taken. So 4x square minus 3xy is a expression it is. then it divides into a 2 because there is a subtraction between two terms. So two terms, which are two terms, 4x square is one term, minus 3xy together we have to take, because we said the terms are added, but here there is a subtraction, means minus together we have to take with the numerals. So minus 3xy, these are called as a terms, 4x square and minus 3xy. In this 4x square, factors are there. Which are those? 4 into x into x. Here minus 3 into x into y. Okay. Then here again, which is that expression, one more I have taken, 5xy plus 10. So these are the terms are 5xy and 10 is a one more term. Factors are 5xy. Here factors are 10 into 1. Okay, I hope you understand. Now go for the next terms, like and unlike terms. Like means, see, when we can say the like and unlike, when the similarities are taken place. When similarities. So which kind of similarity? Okay, which kind of similarities? Here variables, which are variables with orders, or we can call it as a algebraic factors. Algebraic factors should be taken place as a similarities between the terms. Okay, those are called as a like terms. If those are algebraic factors or variables are differences, then those are unlike. Here, when terms have the same algebraic factors are like factors. For example, 2xy if I taken means, in this x and y are the algebraic factors. Only xy should be there on the other terms. Don't consider the numbers or sign, only taken place as a xy. Xy we have to observe. If all are containing xy or yx, xy is also nothing but yx. Why? Because 3 into 2 is nothing but 2 into 3. Same thing, no? That's why. So here xy is a common, same algebraic expression factor are those have. That's why 2xy, 5xy minus 8xy are like terms. Then in the second, x is a common or a same algebraic factor. Here minus 4ab, 7ba. ab and b are same. Don't bother about the sign and numerals. Here now, when terms have a different algebraic factors are unlike terms. So here you can observe, here also xy is there, here also xy is there. Okay, but see here, but xy square is there, here x square y is there. That means in this 1x 2y are there, here 2x y are there. There is a product here, see here. Then can you equate those? Can you equate? No. That's why here y square is there, here x square is there. If it is a x square y, here should be also x square y. Or else if it is a xy square is there, means other should also have a xy square itself. That's why here also same thing. Mn square is there, here mn is there. 7x 12y are the different algebraic factors. Now go for the addition and subtraction of algebraic expressions. How to add, how to subtract the algebraic expression means, here like terms can add or subtract. Unlike terms cannot add and subtract. That's all. Which are the variables or the algebraic factors are same, no? Those numerals we can. Numerals means numbers, or those coefficients we can add or subtract here. So if it is something or another algebraic factors, if they have, means you can keep as it is only. So you can see the rule for that. What is this? The sum or differences of two or more like terms is a like terms with coefficient equal to the sum or difference of coefficients. Just now I said no. Then if the addition and subtraction of terms taken place means we can add the or subtract the like terms of numerals, keeping the algebraic factor as it is. For example, here, see here, I have taken 8xy minus 3xy plus 2xy. See here, see xy, xy, xy. All three terms have a xy as the same algebraic factor means we can add or subtract the numerical factors or coefficients of those. So that means in another way we can take the xy outside with the product, because all are with the product only with the numerals. So now what is remaining in this xy? 8, in this minus 3, in this plus 2. Okay, so 8 minus 3 plus 2. So 8 minus 3 is 5, 5 plus 2 is 7. So answer is 7xy. If it is some number 5x square y is there, you can think. So x square y is not included with these like terms. So what we can keep for all the throughout the process, only 5x square y outside only we have to keep. In the answer also the 5x square y remains the same, because it should not add with the 7xy, because here x square y is there, here only xy is there. So this cannot add or subtract here. I hope you understand. So this is also second rule. Just now I said when we add or subtract two or more algebraic expression, the like terms are added and like terms are left as they are. Okay, now come to the point. Value of an expression, together only I am taking. Actually it is in the next video I should tell, but here only I am including this sentence. Value of an expression is nothing but we have a 2x plus 1. Okay, if we have a 2x plus 1 is there means the value of expression depends on the value of the variable. See, we don't know exact value of 2x plus y 1. What is the value of 2x plus 1? How we can find? Isn't it? So we need it depends on x only. So it depends on the variable. So that variable value is nothing but the value of the expression. That variable value is nothing but value of expression. Then how we can find? If 2x plus 1 is equal to how much we are calculating? Find the value of expression at x equal to 5. If it is the question. Find the value means at x equal to 5 means substitute. So 2 into 5. In place of x, what we have to substitute? Because it is given x as a 5, we have to keep it seems. Then plus 1 as it is only. So 2 5s are 10 plus 1. So what is the value of expression? It is 11. Okay. So this is all about the introduction or a brief explanation of about all algebraic expression. We can go for the exercise now. Okay. Go for the exercise 12.1 of algebraic expressions here. So get the algebraic expressions in the following cases using variable and constant and arithmetic operation. Arithmetic operation means addition, subtraction, multiplication and division. This all you have studied in previous class. Just now I have revised it. So subtraction of z. See, there is a subtraction of z from y. So y. So this is your algebraic expression of first answer. So this is how you have to find it. Then 1/2. 1/2 means it is half. Of means multiplication. The sum of numbers. There is a sum of numbers x and y. See here. This is how we have to make it. Or you can write it as a x plus y divided by 2. Whole thing divided by 2. So this is how you have to write it. Then the number z multiply by itself. So multiply by itself means z into z. That is nothing but z square. If it is a twice means z into z into z means z square. 3 times, no, that's why. Only here the thing is z into z. Okay. Now the 1/4 of the product. 1/4 of the product. Of means multiplication of the product of number. Product of numbers means multiplication of p and q. So in a briefly what we can write, pq by 4. pq is nothing but p into q divided by 4 it is. That's all. So here the numbers x and y both squared and added. So x is squaring and y is squaring and added means x square plus y square here. Then a number 5 added to, see here, a number 5 added to some number, keep it in mind, added to what? 3 times the multiplication product of m and n. So what we can write in a simplification, 3mn plus 5. Then product of numbers means z, y into z subtracted from, so subtracted from 10, it is nothing but 10 minus yz. Then sum of numbers a and b, so sum of numbers a and b subtracted from, so the whole sum only subtracted from their product. Their means a, which numbers are given here, a and b. So their product means a into b. So ab minus a plus b. This is how to make the equations. Now the next question. Identify the terms and their products in the following expressions. Show the terms and factors by tree diagram. Tree diagram means, just now I have in the explanation I have said, no, expression which is that x minus 3 is the expression, and terms means, so which are the two terms, x and minus 3. Factors means, so here 1 into x are the factors. Okay, here minus 3 into 1 or 1 into minus 3, like that. So this is how you have to write with a tree. Okay, all you must do. Identify the terms and factors in the expressions given below. Here also identify which are the terms, which are the factors. Here the terms are minus, you can make it as a table. Okay, like this table you made. Expression, terms, factors. If minus 4x plus y 5 is there means terms are minus 4x and 5. Factors are minus 4x 5, like that. Okay, so remaining is your work. Then the third question, identify the numerical coefficients. See here, numerical coefficients means other than constants in the following expressions. So numerical coefficients are nothing but numbers. So other than constants, here two words are mentioned. See, constants means without variable. See here, in this question 5 is without variable. In this question 1 is without variable. In this question there is no constant value because all are with the variable itself. Okay, then in this here also all are with the variable. Here also all are with the variable. Here also all are with the variable. It is also with variable. It is also with variable. It is also with variable. See, other than constant means except variables which are there. So numerical coefficient. So here which is the coefficient? So only we have to observe the which are having the alpha numerals. That means variables, constants. So which is the coefficient here? -3. Here 1. Because nothing means in this t square, t cube, nothing means it has a coefficient as 1. If it is minus are there means -1, because all are plus, that's why 1. Here 2 and 3. 2 and 3 here. Here 100 and 1000. Here -1 and 7 here. In this 1.2 and 0.8. Here 3.14. Here 2. Here 0.1 and 0.001. How you can write? Like this. See here. Okay, this is how you must write. So the 5 minus 3t square has a factors minus 3t square. In this numerical coefficient is -3. Then here 3 terms are there with numerals t square, t cube. This numerical coefficient is 1. This numerical coefficient is 1. This numerical coefficient is 1. So again here x, 2xy, 3y is there. This numerical coefficient is 1 because nothing means 1. Here it is 1, 2. Here it is 3. So this is how you must write. Then the fourth one, identify the terms which contain x and give the coefficient of x. Which term contain x, and so we have to make it a table like this only. Expression terms with a factor x and coefficient of x. In this term containing x means y square x is containing, and coefficient means other than x we have to write. See, coefficient of x means, so other than x, which are there? X square, y square is there. So y square is the coefficient of x here. In the second question also, see here, which is containing x, this term minus 8yx. So in 8yx, which is the coefficient of x means leaving the x, what is there here? -8y. So 8 minus 8y is the coefficient of x. Here also what is the x containing? X. So it containing variable 1. Here two terms are there, x and xy. So x containing coefficient 1, xy containing y, because leaving x remaining is a coefficient here. Why not 1? Because y into 1 is y only, no, that's why. Here 1 is also numeral, but y is there means you can write it as a y. That's all. So this is all about the numbers. Then the B question in this only, identify terms which contain y square and give the coefficient y square. Here instead of x, y square we have to write it. Then classify into monomial, binomial and trinomial. Yes, I forgot to tell you in the explanation, monomial, binomial and trinomial. Monomial means one term if it is containing the expression. Binomial means two terms. Trinomial means three terms. Okay, only one term containing expression is called as a monomial, two term expression called as a binomial, three term expressions called as trinomial. So here how we can understand? See, this is 1, 2, so it is binomial. So it is only one monomial. So this is 1, 2, 3, so trinomial, like that. So we have to make it like this. So these are the list. Then the sixth one, state whether a given pair of terms of a like or unlike. So like means which are variables same. So here are they like, because the variable is nothing means these are the like only numbers are there. Here x is a variable, so it is a like, and x and y is there, unlike it is, and this is xy and yx, so it is a like. M square p, m p square is there, so it is unlike, and it is xz, x square z square, so it is unlike. Okay, And seventh question, identify like terms in the following. So you have to make a list here which are like terms. So here x y square is a one term, means x y square which are there here, x y square, here 2x, here again x y square, again in this not there. So x y square which are there, only these two are there. Again if it is a y x square, y x square which are there here, here is there x square y, or both are same only, so 2 are there. Again we can got as a 7y, only which are y having only y, see here 2. So like this, so this is how you have to make a list here, see here, and only y terms, only x terms, only xy terms or yx terms. So this is how the in the second list also we made like this, like terms. Then the next exercise, simplify combining like terms. So combining like terms means simplification, means if it is the addition, add it, if it is a subtraction, subtract it. B we can add it, which are b here. So 21 plus minus, first we can write it as a same variables one together, remaining you can write it as a outside, minus 32. See here, these all are having a b, means what I can write, 21 plus 7, only select the numerals with the sign, okay, 7 minus 20, outside I'll write a b, and remaining minus 32 as it is only. So 21 plus 7 is 28, 28 minus 20 is 8, so 8b minus 32. This is how you have to combine the like terms. Same here, next also, see, z square, I'll take from here only. So this I'll show what it is here. So 3a minus 2b minus ab. So here minus is there, means I can include all the minus. You know the integers product. So minus into a, minus into minus, this minus into minus, plus b, plus into minus, minus ab, and plus 3ab plus b minus a. See here, a, b and ab are there here. So make it as a separate, like 3a, which are a again here, minus a, one more minus a here, minus a. So all a get a we have made. Again b you write, minus 2b, again plus b, again plus b, okay. Again which are remaining, minus ab, okay. So I'll cancel this for the time being, there is no space now. So minus ab, minus ab, plus 3ab, okay. So now see here, in this 3 minus a minus a, what it becomes, in another color usually I use. So in this 3 minus 1 is common, a outside. Here in this minus, if you are taken outside, or plus you can write outside, minus 2 plus 1 outside b, okay. Here I'll show, see here, okay. This we made the group, a b separate, b separate, a b separate. So in this 3a minus a, 2a minus a, only one a is remaining. Or you can do it like this also, minus 1 a outside. See what it is here, 3 minus 1 2, 2 minus 1 1. So 1 a is nothing but the a itself, like that. So minus as it is, 2 minus 1 minus 1 b outside, What remaining here? 2 minus 1 1, 1 minus 1 0, 0 into a b means 0 itself here, like that. And minus outside 1ab plus 1ab minus 3. So you know the integer a plus minus 0 minus 1 plus 1 2, 2 minus 3 is minus 1, minus of minus plus 1, so plus ab. So a plus ab here. Okay, this is how you have to simplify here. Next one, 5x square y plus x 5x square, like this are there. So x square y take together, xy square take together, x square take together, y square take together, and you can write it as numbers directly. See, 5 plus 3 8, 8x square y, 8xy square keep as it is, minus as it is. So 5 minus 1 4x square, minus as it is 3 plus 1 2, 3 plus 1 4, 4 plus 3 7, so minus 7y square. This is also we can do it. Okay, now the second question, add 3mn minus 5mn 8mn minus 4mn. So addition means just now we did know same thing, so same variable you can add it, addition, but keeping a plus sign between, like this, plus sign between, like this. Then subtraction is there, subtract 5 minus 5y square from. See, from means that only we have to take first. Subtract means there is a subtraction between 5y square, like this we have to keep first. Then y square as it is, minus of minus plus 5y square, so it is nothing but 1y square plus 5y square, 6y square, like that. Then you can take it this one, so b into 5 minus a minus of a b minus 5. So just to simplify the bracket, so b into 5 5b, again minus a into b ab, minus a into b ab, minus of minus plus a 5a, a5 or 5a, both are same. See, if it is a bracket means this term a is multiplying each and keep like this. Okay, this outside b term we have to multiply to the each and write two terms. Okay, now ab one side, b one side. See, plus 5ab plus 5a plus 5b minus ab minus 2ab. This is how you can write it. Okay, then here fourth one, what should be added to? So what should be added to this number to obtained? So x square plus xy plus y square. So something they are adding is gives the x square plus 3xy, it seems. That means, so if you are writing this means I'll keep this as it is only the box and transfer that side. This term I'll transfer that side. What it becomes? So this becomes 2x square plus 3xy minus of this one, x square plus xy plus y square, it becomes. So this is how, see, if let pb should be added means, then according to the question p we can keep as it is, this throughout transfer that side. Then remove the bracket means this minus applied to the all the terms because it is in the outside the bracket. Then 2x square 3xy minus x square minus xy minus y square, what it becomes? X square 2x square minus x square and y square as it is only, plus 3 minus 1 is plus 2, So this is how x square minus y square plus 2xy should be added. Here also same, what should be subtracted? Here what should be subtracted? So q be the subtraction taken place means here. So minus q. So transfer that side, it also becomes minus. So but q should not be minus. So give the sign to the others. So 5a plus b minus 6 is a given. Here also same thing. What should be taken away from 3x square minus 4y square plus 5x plus 20 to obtain? It is like a second question. Okay, sixth one also, from the sum. So from the sum means these two, subtract this one. So there is a subtraction. You can do it yourself or try it as a homework. So this is about how to add, how to subtract, and how to separate the same variables to add or subtract. Okay, thank you.